Guys, today we are learning about independent and dependent events. When I say that something is independent, what do you think that means? It's by itself. It's not really affected by anything else. Okay, so as it refers to probability, it doesn't have an effect on any other outcome. Okay, it's its own outcome in and of itself. So dependent events, what do you think that would mean? It is going to be affected by some other outcome. All right, so I have two formulas that I need you to write down. Actually, we're not going to write down the formulas yet. Yes, yeah, I'll unfreeze it in just a sec. Okay, two formulas I want you to look at, but we'll talk about that inside the example. All right, so let's read the first scenario. All right, it says a jar contains 5 red and 7 blue marbles. You choose a marble and then replace it. That's the important part that tells you whether or not it's independent or dependent. You choose a marble, you randomly choose a marble, so you're not looking. Then you replace it, the marble. All right, so you're going to have 2 picks, 2 selections. Find the probability that you would choose red, then blue. Find the probability that you would choose red, then blue. All right, so a jar contains 5 red and 7 blue marbles. All right, so if I'm finding the probability of red, what's the probability of red? 5 over 12. Very good. Let me rewrite that. Ooh, separated. All right, so 5 over 12. And then what's the probability of blue? 7 over 12. All right, let me rewrite that one. Okay, times 7 over 12. So here, instead of adding like I did with disjoint and overlapping events, when it's independent and dependent, I actually multiply the probabilities together. Okay, so you're going to need to remember that part. That part's really important. And now you just multiply the fractions. Put it in your calculator. 5 over 12 times 7 over 12. You multiply it, you can either have... you can either do a percentage or a fraction. So if it's a fraction, it's going to be 35 over 144. And if it's a percentage, it's going to be 24%. Did y'all get that? Mm-hmm. Okay. And either answer is acceptable. All right, now let's look at some more probabilities. The probability of red, then red, and the probability of blue, then blue. All right, so go ahead and find the probability of each and then multiply them together. What's probability for red? And then what's the probability that I get another red? 5 over 12 again, because I put it back, so the probability would still be the same, independent. All right, and then that's going to be 17%. All right, and then blue is going to be about 34%. So now with dependent events, it's going to look very similar that you have several choices and you're going to select one of them. But now the difference is that you choose one and do you put it back? No. You select one and you keep it and then you select another one. So now that's going to change the total number of socks available for the second selection. So the probability, it's going to be set up very similar. What would the probability be for selecting a white sock? What would the probability be for selecting a white sock? 12 over 25, which is about 48%. Either one is fine. All right, what about, okay, so we just said that the probability to choose a white sock is 12 over 25, but what's going to happen if I choose a white sock and don't put it back, how many white socks do I now have to choose from for my second event? If I picked one and I didn't put it back, how many are left? 11. Out of what is my total? Nope. I picked one. 24. So you see why we took one from the total. We picked a white, so now there's one fewer white sock or one less white sock, and the same thing goes for my total. Now I multiply those fractions and I get my probability for this dependent event. It's dependent because my first outcome affected my second. All right, so then when I multiply those and write it as a percentage, it's about 22%. All right, now I want you to find the probability that you choose a black sock and then a striped sock. Keep in mind that you don't put the black sock back when you choose it. Okay, we're just playing a hypothetical scenario here. So what's the percentage, what is the fraction for choosing a black sock? 7/25. What's the fraction for choosing a striped sock?
23.
I didn't pick a striped sock. How many striped socks do I have? No. 6/24. I chose the black sock and I did not put it back, which lowered my total for the second selection. You see that? Dependent events. Now I multiply them and I get about 7%. Who got it right? 7%. Okay, so let's solve one more now. Probability that I pick a striped sock, then a white sock. Okay, so striped is what? 6/25. And then since I select one and don't put it back, it's now 12/24. And when I multiply them together, what do I get? What do I get? 3/25? Are you sure? All right. 6/25 times 12/24 is, yes, 12%. 3/25, which is 12%. All right, who got that one right? Okay, much, much better. All right, guys, so that is it. That's your last lesson of Math 7. Congratulations, you finished the book. Awesome. Big, big accomplishment. Great job.